big Q individuals, 36 big Q, little q individuals, and 2 little q individuals. Now you don't have to use this equation right here, but just on these numbers, see if you can figure out the allele frequencies and the genotype frequencies. And let me know if you have some allele type frequency answers figured out. All right, well, how many individuals are there? 200 individuals. How many alleles total are there? Right. There's got to be 400 alleles present in this population because there's 200 individuals. Of those 400 alleles, what's the allele frequency of big Q? The 0.9 is correct. Because we figured it out like this. We said, all right, we know there's 400 alleles present. How many big Qs are there? Well, there's twice this number, twice 162, because each individual here has 2 big Qs. And so what's that? 324? 324 from those 162 big Q individuals, plus 36 more from those individuals, so that's 360. Okay, good. So 360 big Qs, and that's going to equal 9. And we could probably just do this one because we know big QF plus little qf equals 1, so we know this has to be 0.1, but let's work it through just for practice. There's 36 little q's from here. How many little q's from there? 4 little q's, giving us a grand total of 40 little q's out of 400 total, and that's going to be 0.1. Like I said, we could have used this one. Once we found out the frequency of the big Q allele, we could have said, well, it's got to total up to 1 when we add a little q, and maybe just figured it out that way. But anyway, so now we know those. All right, so let's go over here to the genotype frequencies. We know there's 200 individuals. What's the genotype frequency for homozygous dominant? What, out of the 200 individuals, what portion are homozygous dominant? It's going to be, I think 80.8, right. Because we know there's 200 individuals, and out of those 200 individuals, 162 are big Q, homozygous dominant. So their portion, their percent is 0.81. How about heterozygous individuals? 18 or 0.18, and homozygous recessive, 1%, I think? Right. 2 out of the 200 individuals are little q, and that's going to equal 0.01, 1%. All right, are these guys in Hardy-Weinberg equilibrium? If we take these numbers and stick them into the allele frequency equations here, do we get those correct genotype frequencies over there? And I think we do. What's 0.9 squared? 0.9 times 0.9. I think it's going to be 0.81. And what's 2 times 0.9 times 0.1? I'm pretty sure that's 0.18. And what's 0.1 times 0.1? In other words, little q f squared, 0.01. So the equation works. As long as they're mating with each other randomly and the genes aren't affecting survival, this equation will allow you to relate the allele frequencies to the genotype frequencies. You buy it? Okay, now I'm going to end the lecture here. There's a little bit more to it than this. And so I think on Wednesday when we meet again, I'm going to go into this and give you some sheets just like we did in lab where you can do some practice questions on this. But right now we'll end this, and so I'll stay here for 2 more minutes. If you have questions related to today's exam, I'll be happy to answer them.
Yeah. So we're going to have non-Mendelian genetics?
Yes. Yes.